Hello friends. Today we are going to see very interesting topic in Python, regression. So why regression and what is the use of it? See, if you want some functionality, calling the same function definition itself and complete a task, then we can use the regression. So it's called the function itself. So okay, to solve the problem. So it will make the code very smaller. Okay? So that's a way. So here two components play major role. One is base case. Base case means when the execution should stop. Okay. If we are not planning properly the base condition, it will go into infinitely. So infinite loop. Regressive case. This is the case. It's called the definition again. Okay, that's the way it will go. Just I will I will give the normal flow. Just for factorial, just asking one number and calculating the factorial using loops. Okay, loops. This is the approach. What we do, we will take the range. What is the range, and we will multiply with the value, and we will return it. Just I am running it this one. So. So if you see, it's asking, I'm giving 5, that 1 factorial is 120. So similar line, so if we see, if we are using regression, what it's happened, just I am, instead of passing the input, directly I'm calling this factorial with 5. So here, when it should execute, just I am mentioning here, when it's n equal to 0 or n equal to 1, it should exit. This is called base condition. When it should exit, then I will return 1. Else, I am just that a factorial number multiplying, just again I am calling with factorial. This definition itself, I am calling again this function. This is n minus 1. So 5 minus 1, 4. So that's the way I am calling again and again till n becomes 0. This is called regressive call. So whatever the calling, once it's done, it's come to the point when it's written, then what happened? There is two things will happen while regression. One is um, forward one, another one is backward. So when we run here 4, then first time it will come 4 and it will wait to print. So and it will go 4, 3, 2, 1. Then what happen? Then it will come in the backward. Whatever the pending activity in the stack, it will complete and finally it will return to the values. That's the way the regressive work. So whenever we see n minus 1 logic, there we can apply regressive and make it the code very smaller, simpler. Okay. So whenever see the definition itself, the calling of the function, then it's called regression. It should have two condition. One is base and regressive case. Okay. Just I'm executing this. So it will give the same result of the first program. Just the approach is using regression. Okay. So and I am showing one more program, this Fibonacci series. So here it's n minus 1 case. This is a base case. It's a regressive. Just sending the 6. Okay. Send this 6. So calling this Fibonacci series and getting the results. So just I am running it this 0 2. Okay. So this is the Fibonacci series I am printing. So and one more program, it's a regressive sum. So here also what happened? This is the base condition. This is a regressive call. So that's the way we can do whenever we see n minus 1 logic. Then that's n minus 1 or n plus 1, that logic we can apply and achieve solve the problem. Then we can use this regression instead of for loop. We can use this regression. Okay. Just I am running third program. So this is the 6. So I am I entered 3 in range, so the sum of series is 6. So that's a way. So this is the concept of regression in Python. Okay. Uh, Thank you so much. Please subscribe, follow my channel, and share your comment and feedback. Thank you.